Hello everyone. So in the previous session I was doing the problems based on Cauchy's integral theorem and Cauchy's theorem. So let me continue with the same. Here I have a third problem. So evaluate integral closed integral over C e power of z divided by z into z minus 1 into z minus 2 dz, where circle equation is mod z is equal to 1.5. Fine. So before starting with the problem, let me revise the procedure. First step is that we have to check whether the given point z is equal to a lies inside or outside the circle, and if it lies inside the circle, then we have to apply Cauchy's integral formula, that is 2 pi I into fa. What we have, that is integral f of a divided by z minus a is equal to 2 pi I into fa. So this formula I have to apply, but in the theorem it was in the standard form, that is f of a is equal to 1 by 2 pi I into f of a by z minus a, one and the same. If it lies outside the circle, we can apply Cauchy's theorem. So as per the Cauchy's theorem, it says f of z into dz will be equal to 0. So this is the basics that you require. Now coming to the problem, I have already told you this will be of the form f of z divided by z minus a, that is in the standard form. But here I have product of three terms, so we have to split the term. We cannot simply split the term as and how it has, so we have to split that by using partial fraction. So let me consider the denominator. I am going to split the denominator. So in the denominator I have 1 by z into z minus 1 into z minus 2. Let me solve by using partial fraction. So I can write this as a by z plus b by z minus 1 plus c by z minus 2. So you will get 1 is equal to a into z get cancelled, z minus 1 into z minus 2. Hope so you are familiar with partial fraction. Next, b into z minus 2 plus c into z minus 2 goes of z into z minus 1. Fine. Now let me substitute value of z. Suppose if you are going to put z is equal to 1, the terms containing minus 1, so that it will cancel, you will get b. So 1 is equal to z is equal to 1, you substitute, this will be 0. So 1 minus 1 is 0. Next, b into z is 1. 1 into 1 minus 2. Again you are going to substitute z as 1, so 1 minus 1 will be 0. So this term will not be there. So only you left with this. So what you're going to get, 1 minus 2 is minus 1. So the value of b is minus 1. Now let me replace z with 2. So if you're going to put 2, wherever you have minus 2, the terms will go up. So b will not be there, a will not be there. Only you have c. So c into 2 minus 1. So you will get 1 is equal to c into 2 minus 1 is 1. So c will be equal to 1 by 2. Similarly, let me substitute z is equal to 0. So when you put z is equal to 0, this term is not there, this term will not be there. Only term containing a will be there. So 0 minus 1, 0 minus 2. Minus 1 into minus 2 is 2. So you will get a into 2. So a value is 1 by 2. C value is also 1 by 2. Now how can we write this term as? Therefore let me write here 1 divided by z into z minus 1 into z minus 2 can be written as a is 1 divided by 2 into z plus b is minus 1. So I will get minus here, minus 1 divided by z minus 1 plus c is 1 by 2 into z minus 2. Fine. Now let me substitute in the original problem. So how can I write the given integral as e power of z divided by z into z minus 1 into z minus 2 can be written as, I'll just replace this value so that you will get integral over c e power of z divided by 2z plus integral over c e power of z divided by z minus 1. I'm sorry, you have minus here, so you have to put minus here also, plus integral over c e power of z divided by 2 into z minus 2. So in the previous session I have solved one problem, second problem, you was having two terms, so I have taken that as I1 and I2. Here I have three terms, so I1, let me take this as sign as it is, minus I2 plus I3 I can write. Now we have to evaluate for each and every integral. Fine. So let me take I1. So before that, let me write a given circle equation is mod z is equal to 1.5. In the sense, in the number line, suppose if I have 1.5 here, circle will be having radius 1.5. Clear? So distance from here to here will be 1.5. Hope so it is clear. Now let me solve I1 value. Let me consider I1. I1 is given by integral over C e power of z divided by 2z into dz. You have to write dz here also. Clear? Now it is of the standard form. So it is of the form like f of z divided by z minus a. So in place of a we have 0, right? So let me write a is equal to 0. The point a is equal to 0 here. And you can note that a is equal to 0 completely lies inside the circle. Why? Because the circle is of radius 1.5. So distance from here to here is 1.5. 0 lies here. So clearly a is equal to 0 lies inside the circle. Inside the given circle. So I have already told you, when a point lies inside the given circle, we can apply Cauchy's integral formula. So this is what the Cauchy's integral formula is. Let me write. Cauchy's integral formula is given by integral over f of z divided by z minus a into dz is equal to f of a into 2 pi I. It is manipulated from a Cauchy's integral formula. Standard form is f of a is equal to 1 by 2 pi I. Just I have cross multiplied it. One and the same. Now by comparing, here the value of a is 0. So f of z value is e power of z. Let me write here only. So by comparing, f of z is e power of z. So a value is 0. Now what we required is f of a value. In the sense, f of a, in place of a, what I have to substitute? 0. So f of z is e power of z. So f of 0 is e power of 0. It is 1. So f of 0 value will be 1. So solution is, I can write this as e power of z divided by 2 power. This is what the integral I1 is. dz is equal to f of a value is 1. 1 into 2 pi I. So integral I1 value I have obtained as 2 pi I. Clear? So again we have to do the same for the second one. Clear? And one more thing is that so here I have what I have, e power of z divided by 2z I have. Am I correct? You can note that in place of f of z here, let me write here. So here E1 is e power of z divided by 2z. When you compare it with the standard form, that is f of z by z minus a, the coefficient of z should be 1. But here I have 2z. So that is the reason I have to take f of z as e power of z divided by 2. Fine. So I can write, when f of a, when you are going to put a is equal to 0, e power of 0 divided by 2. E power of 0 is 1. So you will get 1 divided by 2 here. So f of a is 1 by 2. So that 2 get cancelled. You will get pi into I here. Hope so it is clear. If you are finding confusion, I will do here once again. See here, I1 value what we have is f of z, standard form I am going to write, f of z divided by z minus a into dz. This is the standard form. In I1 what we have, e power of z divided by 2z. I am doing it again, don't get confusion. Fine. So when comparing it with the standard form, z coefficient should be 1, but here I have 2. So while taking f of z, you have to take full this value. So f of z value will be e power of z divided by 2, and a value is 0. Fine. So when you're going to substitute in a formula, Cauchy's integral formula, you will get it as f of 0 into 2 pi I, right? So in place of z, you have to substitute 0 here. So when you substitute f is equal to 0, you will get e power of 0 by 2. E power of 0 is 1. So you will get 1 by 2. F of 0 value is 1 by 2. After substitution, you will get 1 by 2 into 2 pi I. 2 get cancelled, you will get pi I. So I1 value is pi into I. Clear? It is somewhat clumsy here, so that is why I have written once again. Fine. Now let me solve in the same sense. I am going to solve I2. Let me consider integral I2. So what is the value of I2? I have e power of z divided by z minus 1 into dz. Now here let me take the whole problem as equation 1. Fine. Now I am going to solve I2. So before that, let me compare with the standard form, that is f of z divided by z minus a into dz. Comparing with this, I can write f of z as e power of z, and a is equal to 1, right? And clearly you can note that a is equal to 1, given circle radius is 1.5. So 1.5 will be somewhere here, so that circle will covering that point. Fine. So here a is equal to 1 clearly lies inside the circle. After 1 only you will get 1.5, right? So I can write a is equal to 1 lies inside circle. Inside the circle. Fine. Therefore, we have to apply Cauchy's integral formula. So what is the formula says? F of z divided by z minus a into formula you have to remember is equal to f of a into 2 pi I. Right. So in place of f of z I have e power of z. Now a I have 1. So I have to find the value of f of 1 value. E power of 1. Clear? So e power of 1 is none other than e. So f of a is none other than f of 1. So let me substitute. So f of z is e power of z divided by z minus 1 into dz. This is what I2 is. I2 will be f of 1 is none other than e into 2 pi I. Clear? This is what the value of I2 is. Now I have to calculate I3. So I1 and I2 is finished. Now let me solve I3 by using the same procedure. So let me write here. What is the value of I3 I have? I3 is integral over e power of z divided by 2 into z minus 2. Here also while come into dz. Here also while comparing it the standard form, what we have in the standard form? F of z divided by z minus a into dz, right? So z coefficient should be 1. So f of z will become e power of z by 2. So let me make a list here. So f of z is equal to e power of z by 2. For I3 I am solving. Fine. So e power of z by 2 and a is equal to 2. And you can clearly note that circle is of radius 1.5. So a is equal to 2 clearly lies outside the circle. Right. So a is equal to 2 lies outside the circle. So I have already told you when a point lies outside the circle you have to apply Cauchy's theorem. So Cauchy's theorem says that integral over f of z dz is equal to 0. So by Cauchy's theorem I can clearly say that this value goes to 0. Directly you can write that therefore I3 is equal to e power of z divided by 2 into z minus 2 dz value is 0 by Cauchy's theorem. So when the point lies outside the circle you can directly write by Cauchy's theorem it is 0. Whereas for I1 and I2 it lies inside, therefore I have applied Cauchy's integral formula. Now I have I1 value, it is given by pi I. Let me take this as equation 2. Now I have I2 value here I have. So let me take this as equation 3. I3 value I have 0. Let me take this as equation 4. Now in equation 1 I am going to substitute equation 2, 3, 4. Clear? So let me substitute. So in equation 1, 2, 3, 4, or else I can say, right, on substitution of 2, 8, 2, 3 and 4 in equation 1. So equation 1 I am going to write again. So equation 1 is e power of z divided by, here I have e power of z divided by z into z minus 1 into z minus 2, which is equal to I1 minus I2 plus I3. Fine. Now I1 value where I have, so in equation 2, I1 value I have obtained it as pi I. So let me substitute pi into I minus I2 value where I have, here I have. So I2 value is e into 2 pi I. Let me write here e into 2 pi I plus I3 value is 0. Fine. See here I2 value is e into 2 pi I. So I have substituted e into 2 pi I. I3 is 0. So let me substitute plus 0. So after simplification let me take pi I as common. So you will get 1 minus e into 2, or else I can write this as pi I into 1 minus 2e, one and the same. So here is the problem. Closed integral over c dz divided by z square minus 2, where circle equation is given by z plus 2 is equal to 1. So circle equation is z plus 2 is equal to 1. Before that, what is the standard form of circle? That is mod z minus a is equal to r, where a is the center and r is the radius. Radius is 1 unit. In the sense, suppose if I have a circle something like this, 0, 1, 2, 3, minus 1, minus 2. So here circle is with radius 1. Radius in the sense distance from center to 1. Center is, so compare it with the standard form, that is z plus 2 can be written as z minus of minus 2 is equal to 1 I can write. Fine. So a value will be minus 2 now. Clear? Therefore center of the circle will be minus 2 comma 0. Fine. So minus 2 comma 0 is the center of a circle now. And radius is 1. In the sense distance from the center, that is minus 2 comma center. I hope so you understand the concept, right? So I can express the given circle equation in the standard form z minus a. So when you do that, center will be minus 2, since another coordinate is not known, so it is 0. Minus 2 comma 0 is the center of a circle. Radius is 1. Radius is none other than distance from center to its circumference. So circle will be something like this. Clear? Hope so it is clear for you. Now this is what the circle is given. Now look at the problem. What is the given data? dz divided by z square minus 2. So it is of the form a square minus b square. I don't have here. Am I correct? Suppose if I have a square for this, I can expand by using the formula a plus b into a minus b. So instead I can write this as z square minus 4 as z square minus 2 square. Fine. Now again I can write the same as dz into z square minus 2 square is of the form a square minus b square. So it can be written as z plus 2 into z minus 2. Please make it as 4. Fine. Z plus 2 into z minus 2. Now I can split the denominator by using the partial fraction as we done in the previous problem. So let me consider the denominator, that is 1 divided by z plus 2 into z minus 2. It can be written as a divided by z minus 2 plus b divided by z plus 2. You can write any of the, it's your wish. So I can interchange that. Anyhow I have written, let it be. So a into z plus 2 plus b into z minus 2. So evaluate it. So put z is equal to 2. When you put z is equal to 2, b will be 0. So you will get a value as 1 by 4. Fine. Similarly, put z is equal to minus 2. So when you put z is equal to minus 2, you will get b as minus 1 by 4. Fine. I have used the partial fraction. Now given problem can be written as, see here, dz divided by z square minus 4 can be written as 1 by 4 into, I am going to rewrite this as this. So I can write this as 1 by 4 into 1 divided by z plus 2 into dz minus, why? Because b is minus I have. So minus 1 by 4 into 1 divided by z minus, a value is 1 divided by z minus 2. So a coefficient is 1 by 4. It is z minus 2. Right? Plus b value is minus 1 by 4. So I can write this as minus 1 by 4 into 1 divided by z plus 2 into dz. So if you want, I can write one more step. So from this I can write as, see here, I'll write here only. So a is equal to 1 by 4. 1 by 4 into z minus 2 plus b is minus 1 by 4. So plus of minus will become 1 by 4 into z plus 2. So I have written the same here. Hope so it is clear. I have applied the partial fraction and I have splitted the denominator and I have rewritten like this. Now I can take this as integral I1 and this is integral I2 between minus 1 I have. So that given problem can be written as dz divided by z square minus 4 will be I1 minus I2. Let me take this as equation 1. Now I have to evaluate I1. Let me take I1 as 1 by 4 into 1 divided by z minus 2 into dz. Fine. Now here comparing with the standard form is f of z divided by z minus a. So a value is 2. Right. So a value, you can clearly note that a is equal to 2 lies outside the circle. Right. So you should not write all this diagram in our exam. It is explained only for your reference. Remember. So a is equal to 2 lies outside the circle. Right. So definitely it is not inside the circle. So you cannot check for, further there is no need to check for f of z. If it lies outside the circle, you can directly apply Cauchy's theorem. Thereby its value goes to 0. Anyhow, you have to mention it. Since a is equal to 2 lies outside the circle, outside the given circle, therefore by Cauchy's theorem, I can say given integral f of z dz is equal to 0. Therefore, integral I1 value, I1 is 1 by 4 into 1 divided by z minus 2 dz. Anyhow, it is all closed curves, is equal to 0. So, I1 value I have obtained. Let me take this as equation 2. Now, I have to solve for I2. Let me consider I2 value. What is I2? I have 1 by 4. 1 divided by 4 into 1 divided by z plus 2 into dz. Now I have to evaluate this. Now let me compare it with standard integral. So what is the standard integral value? I have f of z divided by z minus a. Right? Integral over c dz. Now comparing it with the standard form, a is equal to, I can write a as minus 2. Am I correct? Why? Because a z minus a, compare with this, you can write this as z minus of minus 2. So a is equal to minus 2. Now look at the diagram. Clearly minus 2 will be lying inside the circle, right? So I can write a is equal to minus 2 lies inside the given circle. So if it lies inside given circle, I can apply Cauchy's integral formula. Remember, if it lies inside, we can apply Cauchy's integral formula. So let me write Cauchy's integral formula. What it said, f of z divided by z minus a into dz will be f of a into 2 pi I. Am I correct? Now we have to find f of a value. So to find f of a value, compare with the standard form. F of z value is 1, right? So if f of z is equal to 1, f of a is also equal to 1. Compare it with the standard form. See here, in place of z minus a, we have z plus 2. So you can write this as z minus of minus 2. In place of f of z, I have 1. So f of z is equal to 1, meaning is f of a value is 1. So I can write the given integral I2 is equal to 1 by 4 into 1 divided by z plus 2 into dz as f of a value is 1. 1 into 2 pi I. That is 2 pi I. I2 value is 2 pi I. Let me take this as equation 3. Fine. Now let me substitute equation 2 and 3 in 1. 2 and 3 in equation 1. So let me substitute. Equation 1 is integral over dz z square minus 4 will be equal to I1. I1 is 0 minus I2 is 2 pi I. Clear? And moreover, I have 1 by 4 here, right? So I have to write 1 by 4 also. Remember, you are doing major mistake is here. So instead of taking 1 by 4 along with the integral, you just leave 1 by 4 as it is. I'll just change here. See here, why? Because you are going to leave 1 by 4 at last. So that will be major mistake. Let me take 1 by 4 here. So I1 will be only this value. Minus 1 by 4 as it is. So I2 will be this value. I'll just made a change. Why? Because you will get confusion there. Fine. So you will get 1 by 4 into 2 pi I here. So that you will get 2 1s are 2 2s are minus pi into I divided by 2. Therefore, the required integrand value is minus pi I by 2. I'm repeating once again. Once you apply the partial fraction and after you splitting the term, if you're going to term something like this, that is in the denominator, remember you can take the constant outside and you carry that constant along with I1. Please don't take that as I1. Why? Because while applying theorem, it may get confusion. See here, 1 by 4, when you're going to take, it will be with integrand only. So nothing will happen. You will get wrong answer. So that is why you carry the coefficient constant along with I1 and I2. After finding I1 and I2, you carry that constant along with substitution so that you will get correct answer. Hope it is clear. So I'll send you the notes of these two problems. Till few more problems is there. So let me solve in the next session. Thank you.